All right, my friends, here we go. We've got lesson 8.2.3, solving a system of exponential functions graphically. So what we're going to look at today is some cars, and cars can do one of two things. They can depreciate, which means that they lose their value over time, and most cars do this. As soon as you drive it off the lot, boom, your car starts losing value. Sorry. But some classic cars instead appreciate with value. They usually depreciate at first, and then over time, people go, "Hey, that's a really good car," and then it starts appreciating, meaning it gains value over time. All right, Geraldine has a choice to buy a new car. She's got three choices to look at: a new Concorde EX for 27,000, and this depreciates at 6% per year. She can get a used Escalade that was $70,000 when it was new last year, but will be worth $28,672 in 3 years. Or a 1967 Mustang for $18,150, which is appreciating in value, meaning that its value is going up over time. Last year, it was worth $16,500, and the year before that, it was worth $15,000. So we can see that has been increasing over time. All right, so which car would you buy? It's up to you. Well, do you have the money to buy that Escalante? Do you like nice cars that have been around for a while? Stupid lights! Oh, I hate that. Okay, so yeah, do you like classic cars? So you might want the Mustang, or do you want just a nice little Concorde EX? Personally, I'd get like a Concorde because number one, I would not get a car like a Mustang because usually those cars don't have like power windows. They have kind of crappy air conditioning. My first car was a 1990 Nissan Sentra with no air conditioning at all because I lived on the coast and we didn't need air conditioning on the coast because like it was 75 degrees during the summer and 65 degrees during the winter. So I didn't need it. And then I went to Texas and I really needed it. And now I live in the valley here and I definitely needed it. But I drove that thing around for a long time and I sweated all the time. It was horrible. So I wouldn't go for a custom, old car. I'm not kind of a car guy. But anyways, I'd probably go for the Concorde. I don't know what you would buy. So anyways, we want to look at the multipliers for each of these cars. Now the Concorde, this one's the easy one. It's giving us the multiplier. It's depreciating by 6% every year. Now 6% is what it's losing. The multiplier is what it's keeping. So let's call the Concorde, this is going to be the blue one. No, Concorde's definitely, yeah, Concorde's blue. All right, so the Concorde, it's, oops. Oh yeah, I would buy the Concorde. The Concorde, its multiplier would be 1 minus 6%. So 1 minus 0.606, sorry. And so its multiplier would be 0.94 because its value is going down. That's why that number is less than 1. Next up, the Escalate. The Escalate, let's see, a year ago it was 70,000, and then in 3 years it's going to be worth 28,672. Oh, so this is interesting. So a year ago that'd be minus 1. It was worth 70,000. And then in 3 years, it's going to be worth, wow, that loses a lot of value, 28,672. All right, so we need to find that multiplier here. So what we could do is what we've done before. We can say, okay, so if you do the whole thing where you change the values, so you do y, which is 70,000, and then equals AB to the -1. And then over here, you'd get, for the other one, you'd get 28,672. equals AB to the third power. So what you can see here is that the change from here to here is a power of 4. So it got multiplied 4 times. I'm kind of doing a shortcut there. I guess I can do it the long way. Let's do it the long way. Why not? Okay, so in this case, A is equal to that over 28,672 over B to the third. And over here on this one, remember this is over B, so we can change this to put the B to the -1 on the bottom. So I can multiply and I can say that A is equal to 70,000 B. Okay, then we can set these equal to each other. Well, I didn't know I'd do this much math early here. So 70,000 B equals 28,672 over B to the third. I would multiply both sides by B to the third, and I'd get 70,000 B to the fourth equals 28,672. So it looks like I need to divide by 7,000 and then take the fourth root. So let's go ahead and do that on our calculator. So I'm going to take 28,672, divide it by 7,000. We can just do this all at once. We want the fourth root of 28,672 divided by 70,000. Multiplier, 4/5 came out nice. So 0.8 is the multiplier for that one. So that one's multiplying by 0.8 each time, which means it's losing 20% of its value each year. All right, so the escalate its multiplier is 0.8. And then finally, in orange, we're going to do the Tustang. Let's see. Right now it's 18,150. Last year it was 16,500. The year before 15,000. Okay, so we can just take 18,150 and divide by 16,500, and that'll show us how much it's multiplying by. So if I take 18,150, and then last year it was 16,500, now we can find our multiplier. So 18,150 divided by 16,500, 1.1. So it's increasing by 10% each year. We can double check to see if that's working by doing 16,500 divided by 15,000. So we'll just do that, 16,500 divided by 15,000. Yep, still multiplying by 1.1. So yep, it's working out for us. So the Tustang's multiplier is 1.1. All right, so what we're going to do now is we are going to fill out all this deliciousness right here. So let's look at the escalate and get it back to 0. So we said that the escalate was 0.8. So if I'm multiplying by 0.8 going forward, I would divide by 0.8 going backwards. So I'm going to take 28,672. Wait, 1, 2, yeah. So 28,672, I'm going to divide by 0.8. It's 0.8, right? 0.8. So that tells me that in this year right here, what color is this? Green. This is going to be 35,840. And then I'm going to divide by 0.8 again, 44,800. Divide by 0.8 again, and we get 56,000. Now, if I divide by 0.8 again, I should get the 70,000 that it was worth the year it bought it. So remember, this is 1 year after it was new. So let's divide by 0.8 again. Yeah, so we get the 70,000. So last year, it was 70,000, but right this year it's a year old. So year zero for this one is this year, which is when it's a year old. Last year it was 70,000. All right, so let's write the equations for each of these where it says n right there. These are the equations. So starting with the Concorde, the starting value is 27,000. And then the multiplier is 0.94. And then to the x power. For the Escalate, this is 56,000 times 0.8 to the x power. And then finally the Tustang, we've got 18,150 times 1.1 to the x power. So there's our equations for each of our vehicles. Okay, so I'm going to go ahead and pause this in a second and just fill in this graph. Remember, to do the Concorde, all you do is keep on multiplying by 0.94. I'm not going to do pennies on this. I'm just going to do nearest dollar. Escalate, remember, we're just going to multiply by 0.8. The Tustang, remember, we're going to multiply by 1.1 to fill out the rest of these. Okay, so we're going to do 3, 4, 5, and then 10. All right, so let me pause it, and then I'll get back in a second. All right, there's all of our numbers. So again, all I did to get these blue numbers here is I multiplied by 0.94, 0.94, 0.94, 0.94. Now to do this one, I actually used the equation in the calculator. I did 27,000 times 0.94 to the 10th power to get that number there. So for the Escalate, I had to multiply by 0.8 and then multiply again by 0.8. And of course, to get to this one, I just used the equation, plugged in 10 for there. And for this one, I'm multiplying by 1.1 each time. And then to get this one, I just put to the 10th power right there. Oh, I did the wrong color. And, oh well, that makes me sad. All right, anyways. So we're going to graph these. Now the Concorde is going to be in blue. The Escalate, I just love saying that, is going to be in lime green, and then the Tustang is going to be in orange when we make our graph. So I want you to take out a piece of graph paper, and we're going to graph each of these situations here as we see them. And then what we're going to do is we're going to stop looking at the chart and then just look and see what we can find by looking at the graph. Okay, so go ahead and grab some graph paper. You're going to make your x-axis your years, and you're going to make your y-axis the value of the car. So you should probably do it in like, I don't know, like tens of thousands or maybe a couple thousands. Just make it so that it'll fit your graph. Try to use a big piece of graph paper, like I'm going to use something pretty good size like this when I do my graph. And then we'll come back and talk about it once we've graphed it. All right, I'm going to pause. All right, so there I've got my Concorde, and I'm going to try to make the best line possible. I know that those aren't really pretty looking, but we're just going to make the best line possible off of that. And then we're going to do the Escalate. All right, so that's the best I could do, so don't judge me. It's good enough, okay? So there you go. There's my curve. It's not a real steep curve, but remember the value was 0.94. So that means it's really close to being a flat line. Okay, so the next one, Escalate. So starts at 56,000. So 56,000, I'm going to say, is about right there. Sounds good. And let's fill in the rest of the points here. All right, the Escalate ended up looking a lot better. So we can see that this one starts off higher, but then goes down faster because this one's losing 20% instead of just losing 6% each year. So we see that we've got a much more pronounced exponential curve going on here. So let's just kind of draw the best line that we can between these points. Yeah. Looking good. Oh, yeah. That's delicious right there. All right. So there I've got in green the Concorde, and this is the Escalate. So Concorde. All right, last one in orange. We're going to do the Tustang. The Tustang starts off at 18,150. Where's that at? This is 17,500. So I'm going to call it there. That's as close as I'm going to get. All right, let me do the other points. All right, so the only one that's appreciating is my Tustang here. So let's make a little curve going there. There you go. All right, so there's my 3 cars with my 3 exponential curves going there. Okay, now we're going to answer some questions about what we've done here, just by looking at the graphs again. So, here's my first question. Just by looking at the graphs, how can you tell which car is worth the most after 1 year? So let's find 1 year. So here's a year. So everything along this vertical line is 1 year. So after 1 year, all we have to do is find out which one is the highest along that 1 year. Well, I can see here that the Escalate has the biggest Y value when X is 1. So that one would be the one that has the highest cost after 1 year. So after 1 year, Escalate. Because it's got the largest Y value when X equals 1. Next, how about after 5 years? Okay, so let's look at 5 years. So this is 5 years. And here I can see, without looking at that chart of numbers, I can tell now that the Tustang has the largest Y value when X equals 5. And then the Concorde is now in second, and the Escalate has fallen into last place. So at this point, I can see that the Tustang, because it has the largest Y value when X is equal to 5. All right, in about how many years will the values of the Concorde, that's blue, and the Tustang, that's orange, be the same? So let's follow these lines, or these curves, of the Tustang and the Concorde. And here we can see where they intersect. That's where their values are the same. And if I go down here to the x-axis, it looks like they're intersecting when our time is between 2 and 3 years, so about 2.5 years. So just by looking at that graph, we can tell something about the intersection points, about when they're intersecting. We don't know exactly how much this cost is, but by looking at the graph, we can tell that they'll be about the same value at about 2.5 years, depending on how well we made the graph. So they are the Concorde is equal to the Tustang at about 2.5 years. All right, so without looking at the equations, without plugging stuff in, we can use graphs to answer these kinds of questions, which is why graphs are pretty powerful. You can just point at it and get your answers really quick. You don't always get exact answers, but a lot of times you don't need exact answers. You just want approximations. So approximately 2.5 years, we'd get that straight from the graph. All right, last problem, and then I get to go home for the weekend. It's 5 o'clock. All right, 8-118. In 2011, a brand new SUV costs $35,000 to drive off the lot. Okay, in 2014, the same SUV was valued at $22,500. Write an exponential equation to represent this information. And what is the rate that the SUV is depreciating? All right, so let's call the year that we drive it off the lot year 0. Even though it's 2011, we're just going to call this the 0 year. And it costs $35,000. Okay, and then in 2014, so 2012, 2013, 2014, that's 3 years later. Okay, so 3 years later, so that's going to be 3. It says it's going to cost $22,500. All right, so we want to find an equation. Now we already have our A value. That's our starting value right there, our y-intercept. We just need to find out what the B value is. The B value, since we're multiplying 1, 2, 3 times to get there, I'm going to multiply the B value 3 times, and then I'm getting 22,500 divided by 35,000. All right, let's take out the calculator for this. So I've got 22,500 divided by 35,000. Okay, so I get that number right there. I should have used my other calculator. Let me switch calculators just a second. I'm going to pause. I had a better idea. Here's what we're going to do. All right, so instead, we're just going to take the third root because this calculator will do that right away. Ha ha ha. See, big brain. All right, so let's go ahead and just do in my calculator the third root of 22500 divided by 35,000. There we go. That looks good. We'll do 0.863. Sure. So there's our multiplier. So let's write our equation. Our equation then for this is going to be y is equal to, the initial value is 35,000. Our multiplier is 0.863 to the x. So it's multiplying by 0.863 each time. Now the other question for this one is, what is the rate? Sorry. What is the rate that it is depreciating? Okay, so if this is how much it's keeping, this value right there is 1 minus the rate that it's depreciating. So if I do 1 minus r equals 0.863, what I can do now is subtract 1 from both sides. So if I subtract 1, so if I do 0.863 minus 1, I get negative 0.137, and then divide by negative 1, I get r is equal to 0.137. So what's that telling me? It's telling me that it's depreciating at a rate of 13.7%. And there we go. So that's the depreciation rate. So this is how much it's losing. And the B value, our multiplier, that's how much the value is keeping each year. The end. All right. Have a good week. Be good. Make good choices.